Today we are going to discuss about uh, so as I discussed in the earlier session that in today's session I am going to discuss about how to write a Verilog program and then how to simulate it. Okay. So today we are going to see how to write a Verilog program, Verilog HDL program. So first of all, I'll share my PPTs, and then after that we will simulate it in the silence. Okay, so that program will be simulated in the silence. So whenever you are writing a program in Verilog, that program is actually called as a module. Okay, so the module that has three parts. One is the interface, that means there is a port and parameter declaration that will be there. Then after that, body, that means internal part of that module. And then suppose certain add-ons are required, then that will be present. So these are the three parts of any module of Verilog. So here, whenever we are writing a program in Verilog, the first thing that is we need to add a keyword that is a module. So it will be there. There is a module, and then user defined name for that particular module that will be there. That is a module name, and then after that, in a bracket, there will be port list. That means whatever are the input ports as well as output ports that are defined here, and then it is followed by semicolon. And after that, there is a port declaration. That means here just names of the ports that are given, and then after that, ports declaration as well as parameter declaration part that will be there. And then after that, there will be body, that means internal part of that module will be present. So in that part there will be various declaration or various statements will be there. So it may be present in such a way that, it will be there initial block and always blocks, then task functions, then suppose certain lower level modules are there that are going to be used in this module. So instantiation of that module that will be also there. Assignments. So all these parts will be there in this body. And also suppose we want to add certain add-ons, so that will be present in that body. Okay. So after that there will be a keyword that is the end module that is used. Okay. So this will conclude your program. So end module is the last word, keyword that is used in the module. Okay. So it is not followed by semicolon. Remember that each of the statement that will be followed by semicolon. But here this end module is not followed by semicolon. So फक्त तिथे काय असणार आहे end module एवढंच असेल. Okay. So this is the last word in a your VHDL program. Okay. आपण जसं व्हेरिलॉग प्रोग्राम आपण जसं VHDL मध्ये बिगिन म्हणतो म्हणजे स्टार्ट करण्यासाठी प्रोग्राम स्टार्ट करण्यासाठी तसं इथे स्टार्ट मॉड्यूल वगैरे काही नाहीये. फक्त एंड मॉड्यूल म्हणजे मॉड्यूल कधी एंड होणार आहे तेवढाच कीवर्ड अवेलेबल असतो. पण स्टार्ट मॉड्यूल वगैरे काही नाहीये. ओके. किंवा बिगिन आपण करत नाहीये. तो डायरेक्टली तुमचा इंटरफेसिंग झालं म्हणजे पॅरामीटर डिक्लेरेशन पार्ट झाल्यानंतर बॉडी येते आणि बॉडीमध्ये मग आपण तुमचे जे काही स्टेटमेंट्स असतील ते आपण जे असाइनमेंट स्टेटमेंट्स आहेत ते आपण डिक्लेअर करतो. ओके. So this is about the overall structure of this Verilog program. That is the module. Okay. So in a Verilog, module is the principal design thing. Okay. So this indicates the name and code list. Then the next few lines which specifies the input or output type and width of each port. Okay, so that will be defined. If the width is not defined, then by default it will be taken as a one. Otherwise, it will be depending on the width, it will be multi-bit port. Okay. Then the port variables that must be declared by wire WN. So that means different types of wires or register. If that port variable is again not declared, then by default it will be taken as a wire. So normally we are inputs are wire because data is latched inside the model, and outputs are registered. Okay, so it will be this will be the some structure of the module. Okay, so this is one example, that is a module. Then after that, the name for that module. So here the name given to that module is a sub underscore add. Okay, so this is the user defined name. Now remember that Verilog is a case sensitive language. That means whatever name that you are giving, so that you have to maintain the same case for each of the letter that you are using. VHDL मध्ये हा प्रॉब्लेम नव्हता. तुम्ही कुठल्याही केसमध्ये लिहिलात आणि नंतर कुठेही काही वापरला काही फरक पडत नाही. पण इथे मात्र तुमचे जे काही युजर डिफाईन्ड वर्ड ते सेमच केस वापरायला. Okay. At the same time, keywords are in a lower case. Okay. So all the keywords that you need to use in a lower case, and then it will be followed by a uh, ports. Okay, so port list will be there. So here you can see there are different ports. That is a add, then in one, in two, and out. Okay. Usually this is the good practice to define or declare output ports first. Okay. Though here this output port is after, but this is the good practice to define output port first, because whenever you are instantiating any module in another model, so in that case, whatever are the ports that are listed first, that will be considered as the output. Okay. त्यामुळे तुमचे जे काही तुम्ही पोर्ट डिक्लेअर करता ते पहिल्यांदा आउटपुट पोर्ट डिक्लेअर करावे आणि नंतर मग इनपुट पोर्ट डिक्लेअर करावे. Then there is a now here these ports are declared here or listed here. This is not declared, but actually these are listed here, and after that we need to declare. Okay. So the first port, that is the add, that is declared in the way that is the input. Okay. So as this is the input port, so input and then the name of the port. Okay. So that is a add port. So it is followed by a semicolon, and then as there is no any type that is declared for this port, so by default it will be considered as a wire. Okay. Again, the length is also not declared, or width is not declared, so it is a single bit. Then after that, input in the square bracket 7 as to 7 colon 0. So that means this is a 8-bit port. Okay, input port, and as both these in one and in two, these are 8-bit input ports, so these are separated with the comma. Okay, so all these ports, the same type of ports can be declared in a one line by separating this with the comma and then semicolon. Okay, now these ports are of the wire type, so this is mentioned here, or this is declared that is a wire in one and in two. So whenever you are want to declare about the type of that port, so that is will be declared here. And then output port, that is also a multi-bit port. So output in the square bracket 7 colon 0, output, that is out, semicolon, and it is of the register type. Then after that there will be certain statements. that we need to assign. So that will be present, and then after that end model. So actually this end model, this should be continued. There should not be any gap, and this e should be smaller. Okay, in a lowercase. So that is about the example of how we are declaring the codes for this Verilog program. Okay. So let us go for the example of this Verilog. So here we are going to discuss or simulate half adder. So as you all know, half adder, that is the circuit which adds two bits. Okay. So two binary digits are the inputs and two binary digits that are output. One is the sum and another one that is the carry. So that means it has two input ports and two output ports. Okay. So this is a very simple circuitry that we are going to discuss first, and after that we are going for the uh, simulation of this program. Okay. So when we are discussing about output for half adder, output sum, that is nothing but A XOR with B, and the another output, that is a carry, that is a and B. Okay. So these are the Boolean expressions for the output of half adder. Okay. Everyone knows about this. So now let us see how to write a program for this half adder. Okay. So this half adder, that is nothing but a circuit which adds two bits and gives two outputs in the form of sum and carry. ओके. तर मग आता आपल्याला जेव्हा प्रोग्राम लिहायचा आहे तेव्हा आपण स्टार्ट कसं करणार आहे, तर पहिल्यांदा कीवर्ड यूज करणार आहे मॉड्यूल. ओके. अँड देन गिव्ह अ नेम टू दिस मॉड्यूल. So we are going to give the name as a half adder, and then after that let me correct this. Actually I have taken this input port first and then output. It will not give you a error whenever you are singly design simulating this. Let me show first this. म्हणजे तुम्ही जर आधी इनपुट पोर्ट लिहिले आणि नंतर आउटपुट पोर्ट ची लिस्ट मध्ये लिहिलं तरी काही फरक पडणार नाही. तुमचा प्रोग्राम हा करेक्टली आउटपुट देईल. पण जेव्हा तुम्ही हा हाफ ॲडर, जर समजा तुम्हाला फुल ॲडर डिझाईन करायचं आहे की ज्याच्यामध्ये तुम्ही स्ट्रक्चरल मॉडेलिंग करताय, म्हणजे तुम्ही हाफ ॲडर यूज करून तुम्ही जर मॉडेलिंग करत असाल तर त्यावेळेस तो इन्स्टन्शिएट जेव्हा केलं जाईल हा कंपोनंट ॲज अ हाफ ॲडर, हा कंपोनंट, तर तुमचे जे पहिले पोर्ट्स आहेत ते आउटपुट पोर्ट्स म्हणून कन्सिडर केले जातात आणि मग जे दुसरे पोर्ट्स नंतरचे आहेत ते ॲज अ इनपुट पोर्ट्स म्हणून कन्सिडर केले जाते. त्यामुळे मग जेव्हा तुम्ही डिफाईन करताय तेव्हा शक्यतो प्रिकॉशन घ्या की तुम्ही आधी आउटपुट पोर्ट डिक्लेअर करताय आणि नंतर इनपुट पोर्ट. आता मी असंच ठेवते इथे दाखवण्यासाठी, पण you may correct this. Okay. So this sum and carry, these are the output ports, and then A and B, these are the input ports. Okay. So first of all, these ports are listed, and then after that, it is declared that input A is the input port. So it is of the it is one bit, as it there is no any length width is declared, so it is a one bit. Then output input B, then output sum and output carry. So all these are the inputs and output ports for this half adder. Okay. And then after this we need to declare the body of this model. Okay. So आता इथे आपल्याला दोनच स्टेटमेंट्स आहेत सम आणि कॅरी साठीचे, आणि दोन्ही म्हणजे जस्ट सिंपल असाइनमेंट स्टेटमेंट आहेत. तर त्याच्यासाठी म्हणून मग आपल्याला कुठलाही ऑलवेज ब्लॅक किंवा इनिशियल ब्लॉक यूज करायची गरज नाहीये. सो वी कॅन सिम्पली assign these statement. So keyword is used as assign sum. म्हणजे इथे काय होणार आहे, assign sum जेव्हा म्हणतो तेव्हा sum साठी काही जे त्याच्यानंतरचं जे स्टेटमेंट असेल ते असाइन होईल. ओके. सो असाइन सम इज इक्वल टू ए exponential mark and b a exponential b, okay, followed by semicolon. So this exponential, that mark that is used for the bitwise expression. Okay. So though if you are using a multiple bits, so it will be XORing bitwise. Okay. So this is a A XOR B, and another statement that is a assign carry that is equal to A and B. Okay. So for this A and B, the ending operation साठी आपण operator वापरतो ampersand. So A ampersand B, that is the statement that is used for carry. Okay, and then as we need to now conclude this model, so we have to use a keyword in module, and remember that there is no any semicolon after this end model. Okay, end model नंतर कुठेही semicolon असणार नाही, पण आधीचे जे statements असतील त्याच्यानंतर मात्र semicolon will be there to uh, express that it is the end of that statement. Okay, so this is about the program for half adder. Now let us simulate this program. So already I have designed this program. जो आधीचा प्रोग्राम आहे तोच मी घेतला. आपण ऑलरेडी हे बघितलं होतं, त्यामुळे तोच प्रोग्राम मी इथे आता दाखवते तुम्हाला. तर आपण डिफाईन काय करू, म्हणजे ज्याप्रमाणे आता आपण परत झायलिंग्स यूज करणार आहे, तर झायलिंग्स यूज करताना तुम्हाला नेहमीप्रमाणे नवीन प्रोजेक्ट करावा लागेल. सो यू हॅव टू क्रिएट न्यू प्रोजेक्ट, अँड देन इन दॅट instead of selecting VHDL as a HDL language, now you need to use a preferred language as a Verilog. ओके, आणि त्याच्यानंतर बाकीच्या ज्या स्टेप्स आहेत त्या VHDL मध्ये जशा करतो तशाच करायच्या, म्हणजे न्यू सोर्स ऍड करायचा. आता हा न्यू सोर्स ऍड केल्यानंतर तिथे आपल्याला Verilog मॉड्यूल सिलेक्ट करायचं. सो Verilog मॉड्यूल सिलेक्टेड, and then after that you need to write ports there or list ports there, or you can go for the programs by skipping that step, and in a program you can write a this all these ports. Okay, so आता इथे मी ऑलरेडी हे सगळं स्टेप्स फॉलो केलेले आहेत आणि त्याच्यानंतर प्रोग्राम पण लिहून ठेवला. सो आय विल शो इट टू इट. सो देर इज अ मॉड्यूल विच इज अ कीवर्ड अँड देन हाफ ॲडर. ओके, आता जेव्हा याच्यामध्ये आणखीन एक आहे की आपण पहिल्यांदा फक्त पोर्ट लिस्ट डिक्लेअर करून त्याच्यानंतर पोर्ट डिक्लेरेशन सेपरेटली करू शकतो, किंवा पोर्ट लिस्ट मध्ये तुम्ही इनपुट पोर्ट आहे की आउटपुट पोर्ट आहे हे डिफाईन करू शकता त्याच ब्रॅकेटमध्ये, म्हणजे तुमच्या तिथेच तुमचं क्लिअर होऊन जाईल की हे कुठलं पोर्ट आहे. ओके, सो हिअर आय हॅव डन इन दॅट वे. सो सम इज द आउटपुट पोर्ट, सो आउटपुट सम, then output carry, then input A and input B. So all these ports that are separated with a comma and then bracket completed and then semicolon. And after that there is a assign sum equal to A exponential B, uh, and the assign carry is equal to A ampersand B. That means A and B, and then end node. Okay, so this is your program for this half adder. Okay, so let us, I have already saved this, but let us save this once again. Go for check syntax. बाकीच्या ज्या स्टेप्स आहेत ज्याप्रमाणे आपण VHDL मध्ये करतो त्याचप्रमाणे करायचे. Right, you can pick for RTL schematic also. So here is the RTO schematic for this half adder. And after that, now as this simulation that is for this half adder that has been completed, but we need to test this circuitry or this program. So for this, we need to write a test bench. So for writing a test bench again, as per VHDL program, we need to add a new source in the Verilog also. So right click on the new this half adder project, and then here you need to now select Verilog space picture. Okay? So you need to select this Verilog space picture, give the name, and then write there a test bench for this Verilog program. So already I have done this part, so I will skip this, and then I will just open this test bench. Okay. So here तुम्ही जेव्हा याच्याप्रमाणे ओपन करता Verilog मध्ये तर तेव्हा तुमचं एक स्केलेटन तिथे पण क्रिएट होईल as per VHDL, and then you need to just give the stimulus there. Okay, so here there is a module that is a half adder test bench that has been created. Then all these ports declaration part will be there, and after that we need to give a stimulus. Okay, so here for wait statement it is the syntax is that is hash, and then whatever is the time period that you need to mention. Okay, so hash 100, that means it will wait for 100 nanoseconds. And then we have given the stimulus like A is equal to 1, then B is equal to 0. So that means it will give the sum of 1 and carry that is equal to 0. Then A is equal to 0, B is equal to 1, that is the another stimulus. Then A is equal to 1, B is equal to 1, that is the next one. And then after that, again, in the initial state, that is A is equal to 0 and B is equal to 0, that will be there. Okay. And then end of this initial block. So here actually, there will be initial big block that is used in this program. Okay. So end of that initial block and then end of the module. Okay. So whenever we have this end statement, so there would not be any semicolon. So let us simulate this. So here, whenever A is 0, B is 0, sum is 0, carry is 0. Okay. A0, A1, B0, sum is 1, carry is 0. A0, B1, sum 1, carry 1, 0. And whenever A equal to 1, B equal to 1, sum is 0 and carry is equal to 1. So as per the truth table, we are getting the output. So that means whatever program that we have written, that is correct. Okay. So is this clear to you all? सगळ्यांना लक्षात आलंय का? Yes. कुणाला काही डाऊट आहे का?
No, ma'am.
So now let us proceed further, and the next is the full adder. Now what is full adder? Full adder is the circuit which adds 2 bits plus 1 carry. That means actually it is adding 3 bits. So A, B and C, and it gives the output in terms of sum and carry out. Okay. So Boolean expression for sum, that is equal to A XORed with B XORed with C, and Boolean expression for C out, that is a and B or seen ANDed with A XOR B. So that is the Boolean expression for full adder. So now is it possible for you all to write a program, Verilog program for this full adder? So write a program for full adder, Verilog program for full adder. Okay, I have given a Boolean expression. I will just display this program so that it will be easier for you to write program for full adder. Okay. Now in the same way, just write Verilog program for full adder. So you can take 5 minutes to write this program. Let me know once you finish this.
Completed,
Okay,
ma'am.
others? So this is the program for full adder so module. The name, that is a full adder, that is the name that I have given. Then the port list, A, B, C in, S and C out. Again, I'm telling here I have used input port first and output afterwards. But keep a practice to define output port first. Okay. Then input, that is a wire A, B and C, and then output register, that is S and C out. Okay. So these are the output ports. Okay. So after that, assign S is equal to, that means sum is equal to A XORed with B. So for this XORing, the operator used is a exponential, A exponential B exponential with C. And another statement, that is assign C out is equal to A and B, A ampersand B. For ORing operation, the symbol used, that's the operator used, that is a vertical bar. So A ampersand B, or in the bracket A exponential B and ampersand C. Okay, so that means this statement is A and B, or A XORed with B and ANDed with C. Okay, so this is the assignment statement for carry out. After that, there is a end module. So this is the VHDL program, Verilog program for full adder. ओके, इतक्या वेळा आपण VHDL बोलतो की त्यामुळे माझ्या तोंडात तो VHDL हा बसूनच गेला. बट दिस इज नॉट अ VHDL, दिस इज अ Verilog program. Okay, so remember this. So let us see whether I have this program already done. Already we have done this.
मॅम तुमचा माईक ऑफ आहे.
ओके, म्हणजे याच्या आधीच जे काही बोलले ते तुम्हाला नाही कळलं. सो इज
मॅम
दिस
हा
प्रोग्राम
कोड
इज क्लिअर?
मॅम आणखी एकदा सांगा ना हा कोड.
Yes, okay. Here we have a module that is a fadder underscore Verilog. Okay, so this is the user defined name. म्हणजे हे जे तुम्ही कुठलंही देऊ शकता इथे. फक्त लक्षात ठेवायचं की आपण इथे देताना फक्त लेटर्स आणि अंडरस्कोर आणि digits. Okay, so एवढंच देऊ शकतो. So this is the name given and then after that there will be port list. Okay, आता पोर्ट लिस्ट तुम्ही जेव्हा डिफाईन करताय तेव्हा फक्त नेम्स तिथे मेन्शन करू शकता किंवा ते टाईप कुठला आहे, म्हणजे इनपुट आहे की आउटपुट आहे की इनपुट इन आउट आहे, ओके, ते पण मेन्शन करू शकता. सो ऑलरेडी म्हणजे हे सेपरेट करून कॉमनली सेपरेट करून प्रत्येक म्हणजे तुम्हाला जी नंतरची स्टेटमेंट पोर्ट डिक्लेरेशन पार्ट करावा लागतो तो करावा लागणार नाहीये. You can minimize your program by mentioning type in the port list itself. So here I have done this in the same way. So output sum, then output carry, input A, input B, and input C. All these are the ports of this model. Okay. After that, there is a assignment statements. So assign sum equal to A exponential b exponential cn, that means a XORed with b XORed with cn. Okay, and after that we need to assign a statement for carry also. So assign carry, that is equal to, okay, now actually when we were discussing about this code, so that time I used some another boolean expression, but here we have this expression also for carry. So that is a anded with b or a anded with cin or b anded with cin. Okay, so this is the another boolean expression for carry. म्हणजे तुम्ही कॅरी या दोन्ही वेनी लिहू शकता, तर त्यासाठी मी इथे दुसरं वापरलं. सो that it will give a same result. Okay, and after that there is a end module. Okay. Then let us simulate this. So for this, this is the code. Okay, and this here we have given the stimulus for different. So this is the stimulus. Okay, so let us take syntax first, and then simulate. So here, whenever all inputs are 0, sum is 0, carry is 0. When any one of the input is 1, sum will be 1, carry will be 0. म्हणजे आता जर तुम्ही इथे बघितलं तर फक्त A1 आहे, बाकीचे 0 आहेत. इथे B1 आहे, बाकीचे 0 आहेत, तर सम 1 आहे, कॅरी 0 आहे. इकडे Cin 1 आहे, बाकीचे दोन्ही म्हणजे A आणि B 0 आहेत, तर सम 1 आहे, कॅरी 0 आहे. Now if two inputs are 1, any of the two inputs are 1 and another one is a 0, third one is a 0, then carry will be 1, sum will be 0. तर इथे जर तुम्ही बघितलं तर A आणि B 1 आहेत, carry 0 आहे, Cin 0 आहे, तर carry out, that is 1 and sum will be 0. Okay, in this case A आणि Cin 1 आहेत, B 0 आहे, तरी पण sum तुम्हाला 0 भेटेल आणि carry 1. Here B is 1 and Cin is 1, A is equal to 0, sum is equal to 0, carry is equal to 1. That result you are getting. And if all the three inputs are 1, then sum will be equal to 1 and carry will be equal to 1. Okay, so that means you are getting the result as per the ट्रूथ टेबल. ओके, म्हणजे तुमचे जे काही वेवफॉर्म्स येतात आणि तुम्ही स्टिम्युलस जसं दिलेलं आहे त्याप्रमाणे तुमचं आउटपुट हे तुमच्या ट्रूथ टेबल मध्ये जसं एक्सपेक्टेड आहे तसंच येतं. याचा अर्थ तुम्ही डिझाईन केलेलं सर्किट हे बरोबर आहे. ओके, सो दिस इज अबाउट द फुल ॲडर. कुणाला काही डाऊट आहे का याच्याबद्दल? If anyone has doubt about this,